This is an example solution to a problem from the Pendulum Period problem set from SciencePrimer.com. The question I'm going to use is the following. Given that the acceleration due to gravity on a newly discovered planet is 6.1 meters per second squared, calculate the period of a pendulum with a length of 4.18 meters. So there's three pieces of information here. We're given two, and we need to find the other. So we're given the acceleration due to gravity, we're given the length of the pendulum, and we need to find the period. The formula needed to solve this question is how the period of a pendulum relates to the length, its length, and the force of gravity. The formula is 2 pi period or time equals 2 pi times the square root of the length over acceleration due to gravity. So this is the equation we need. Before I go ahead and solve this problem, I want to talk about the problem set in general, because there are variations of this question in the problem set. In all cases, you're given two pieces of information and you need to find a third. You may be given time and gravity and asked to find length, and you may be given length and time and asked to estimate acceleration due to gravity. So if you're asked to find the period, use this equation. If you're asked to find gravity given length and time, this formula needs to be rearranged to solve for gravity. The first step in doing that, because the gravity is in this square root, is to square both sides of the equation. So time gets squared, 2 gets squared becomes 4, pi gets squared. Since these are both having the square root taken of them in the original equation, the square root symbol just goes away and you end up with length and gravity. Then need to multiply both sides by gravity to get the gravity out of the denominator. So gravities cancel here and you end up with gravity times time squared equals 4 pi squared times the length, and then if we just divide both sides by time squared, the time squareds cancel here, and we end up with the second format. If you're given the period of a pendulum and its length, to find gravity, gravity equals 4 pi squared times the length of the pendulum divided by the period of the pendulum squared. And so this is the second form of the equation. And then finally, if we're asked to find length given period and gravity, we can go ahead and multiply both sides by time squared again to get back to this structure. So back up a step. So we have 4 pi squared length equals gravity times time squared. Divide both sides by 4 pi squared, 4 pi squared. They cancel over here. We end up with length equals gravity times time squared over 4 pi squared. So here's the third format. So if you're asked to find length, asked to find gravity given length and time, or again asked to find the period given the length and gravity. This problem set doesn't require you to memorize these formulas, although I would recommend it's a good idea to be able to manipulate this. So given this form of the equation, it would be very useful to be able to solve for either gravity or length. But if you don't want to do that for this problem set, you can click on the hint below the question, and the three forms of the equation are shown. And if you show the hint, what you need to do is then just be able to choose among the three forms of the equation, depending upon which of the three variables you're asked to find. So now that we've talked about the different forms and the different types of questions you might be asked, let's get back to the actual question here. Since we're asked to find the period, it's this structure we need. The period equals 2 pi times the square root of the length divided by gravity. So the period equals 2 pi, and let's go ahead and substitute numbers in here. The length is 4.18 meters, 4.18 meters, and this is divided by 6.1 meters per second squared, which is the acceleration due to gravity on this planet. Pull in the calculator. It's easiest to deal with the numbers under the square root sign first, so 4.18 divided by 6.1 equals 0.685. We'll take the square root of that. We'll then multiply this by 2, and then multiply by pi to get the final answer, which is 5.2. So coming back to here, this equals 5.2. And now the last thing we need to do is figure out what the units are here. I didn't deal with the units when I was dealing with the numbers, so let's pull these units out and just look at how how they cancel out. So we start with meters over meters per second squared. In order to get meters per second squared out of the denominator, to rearrange this equation, this is equal to the square root of meters seconds squared over meters. Just flip this over to get it out of the denominator. Now meters cancel, and we end up with the square root of seconds squared. The square root and the square cancel, and the final units of our answer is seconds. So the answer to this question is 5.2 seconds.